As a professional involved in electricity delivery, the T&D World podcast and tdworld.com is your definitive source for breaking news, industry updates, and more. We've got you covered from transmission to distribution and everything that affects the power grid. And now, on to today's episode.
Hello and welcome to T&D World Live podcast. I'm Jeff Postlewaite, managing editor for T&D World. And the subject we have today here is wildfires. We just wrapped up doing our wildfire issue at T&D World, but as I was just saying before the recording, it's a topic that never really stops for people, for utilities. They're working around the clock and around the calendar year. So today we have Andy Abranches, who is VP of Wildfire Mitigation for Pacific Gas and Electric. Welcome to you, Andy.
Hey, thank you, Jeff. Thank you for having me on this podcast.
Sure, no problem. We really appreciate a representative from a utility with as much going on as PG&E. So I guess I'll just jump right in. About PSPSs, one of the top goals for many utilities with regard to wildfire mitigation is how to make sure that public service power shutdowns are a last resort. So can you tell us how or whether PG&E has been successful in the past year at reducing the number of PSPSs or limiting their impact on customers?
Yeah, I think the largest PSPS event that PG&E took was in 2019, and that was very early in our journey on PSPS. We had started getting our feet wet with doing it in 2018, and then when the weather hit in 2019, we were scrambling, but we were committed to making things safe for our customers and making sure that a PSPS event did not result in the wind that happened did not result in a catastrophic fire. And we were successful, but that PSPS event in 2019 took out almost 1 million customers across our service territory. And so, from that, there were a lot of learnings, and we've had the benefit of a steady improvement in the program. Effectively, last year in 2025, we only de-energized, impacted basically around 17,000 customers, between 17,000 and 18,000 customers last year. And the prior year in 2024, it was closer in the range of 50,000 customers, which really begs the question in terms of, have we reduced the number of PSPS events? The real answer to the question is, we don't know, simply because when you think of it from a PSPS event, it's really driven by what are the weather conditions that will manifest itself. So the way we like to think about it is we are ready with regards to that. What we have done on the system is sectionalize. We've sectionalized it sufficiently so that when we do need to take PSPS, it's very focused on where the need is needed. And I think in that regard, we've made some big strides. To put it in context, right, though, is basically if I take the 2024 data and I compare it relative to what we landed up doing in the past, by sectionalizing alone, we've mitigated about 450,000 customers because we did sectionalizing work over the multitude of years prior to 2024. That gives you the best available, just measure for the sectionalizing work. There's also massive advances that have happened on the weather, on the weather forecasting. So trying to be a lot more precise, putting AI capabilities onto our weather stations. So we have a look ahead. So we know when the weather has passed or when the weather is forecasted to have passed, so that we can recover from that as quickly as possible. So the recovery is just as important to us in that.
Right, and I do want to get into more on the AI aspect and the weather stations, but wildfires being a huge issue for customers, but electricity bills are too. So I was wondering if you could talk to us a little bit about how PG&E is working with regulators and policymakers and others on making power grids more wildfire safe, but still delivering affordable electricity.
Yeah, so there's no question that us responding to the wildfire challenge, right, has required us to spend a fair amount of dollars on just redoing the system radically. I want to say upfront, I think customers benefit from that in a massive way. If you look at the data from 2023, 24, and 25, we have not had a significant fire in PG&E's service territory. Now, our work is never done, and it requires vigilance. But I think the disruption from a large-scale fire is extremely challenging for a community and for the surrounding regions. I think we can see the impact that's happening in down in LA as a result of the Eaton and Palisades in early 2025. But we're very focused on cost reduction too. So the question is, how do we get better? Basically, how do we provide that level of protection, plus and still work to optimize the O&M spend, optimize the capital expenditures that we're putting forward with regards to wildfire. So on vegetation as an example, right? We were doing a vegetation program. We realized over the course of it how good was the vegetation program, and we basically pulled it back. We had a pretty large program called EVM, which we decided to pare down because we had a better mitigation in terms of enhanced power line safety settings at a much lower cost on that regard. We're continuing to streamline that and reduce that footprint of that we need to do the vegetation work by using remote sensing. So if you do remote sensing, it tells you where you need to focus and where you don't need to focus. Where you don't need to focus, that impacts the cost of running that program and the follow-on work. Similar, we're working aggressively to reduce the cost of undergrounding. While undergrounding is, $4 million, and it's the best mitigation for the long term, but using rock wheels, using aggressive trenching technologies, pioneering new technologies like ground level system hardening, all of it is intended to lower the per unit cost of that work as it's required. So those are examples. The PSPS example actually that I was highlighting, right? Because we've done that, the fact that you have to take a very narrow PSPS, it means the expenditures on PSPS are lower. The area you need to patrol is low. We'll get into the continuous monitoring portion if you want, but that gives you a trifecta. It not only gives you safety, it gives you reliability, and it'll result in lower costs as we execute this over time.
Yeah, I do want to talk about continuous monitoring too, but you had mentioned customer benefits. I'm interested in how utilities get out and sort of make the case. How is PG&E reaching out to its customers and let them know where their rate dollars are going in terms of making the grid more safe from wildfires?
Yeah, we're very intentional about showing customers where their dollars are going. One of the primary ways we do that is through Your Energy Dollars at Work. It's a video series, really, which highlights real projects happening in communities across our service territory, whether that's safety upgrades, reliability improvements, or new technologies. It's really about connecting the dots for customers and showing how these investments are being put back into the communities where they live. I'm repeating myself a little bit, but a good example is our undergrounding work. We've used the series to highlight how newer, more efficient equipment like trenchers can speed up projects and help manage costs while building a safer, more resilient grid. So customers really get to see that, see those investments in action right in their hometowns.
Good. Well, getting back to the question of monitoring, I read on your website that PG&E has a continuous monitoring center, which is sort of supposed to take the pulse of the power grid and help prevent wildfires. Can you let me know how this works and what technologies does it use specifically? We have a lot of engineers in the audience, so don't be afraid to dig in on that a little.
No, I'm very excited about this. And to be frank with you, I think we just opened up the continuous monitoring center in the earlier part of this year, in January and February this year. But what is continuous monitoring? If you think about how we go about doing our inspections today, it was very much looking at the grid, looking at the overhead infrastructure, either with somebody on the ground, or even as we got more advanced with using aerial drones taking pictures, and then looking at those pictures to identify the anomalies. Continuous monitoring is a very different way. It's you're listening to the grid. And when I say listening to the grid, you're looking at all the signals that are coming from the power flows that are happening on the grid, or literally in some cases, the sounds that are happening on the grid, and interpreting from that as to what is taking place out in some fairly remote areas. So the technologies at play is I'll start first actually with these sensors that we call grid scope sensors. These are sensors that are not connected to the grid. They're about a shoebox size. You place them on a distribution pole. You can also place them on a transmission structure. But what it does is basically it's got a suite of sensors that is listening. If anything contacts the grid or comes in contact with the lines, right, it basically sends off a series of vibrations. Those vibrations, then sound can be heard if it's close by, but the vibration can be felt for sometimes like 3 to 4 miles away on all of the distribution poles on either side. And the sensors pick that up, and based on that signature pattern of the sound, they send us a signal. So they send us a signal. They only send us those signals in an exception basis. So they're listening around the clock, but they send us a signal in an exception basis. Now we know where exactly to dispatch a troubleman to see. And also by the type of the signature pattern that comes in, you have a general idea when you have a library of this as to what has happened. So when the troubleman is coming there, they know what to look for. Are they looking for a squirrel on the line? Are they looking for, hey, a bird came into contact? Or, you know what, actually, was it a cow that rubbed against the pole that kind of sent this, right? Are there damages to the cross arm? That's the level of information you get. The other technology is early fault detection. This is the radio frequencies that are around the lines, and you've got to put, these have to be connected to the grid. They go every 3 to 4 miles, but they're looking at basically what is that radio frequency field around the lines and reading it for normal signature pattern, and then any baseline changes from that. And then again, it's a signature pattern a recognition system that one goes into the cloud, gets processed, sends us a signal and says, hey, something is happening here in this vicinity, and it's within literally 30 feet of each other. You can go in there and you'll be surprised what we can find. So that's another technology. I won't go to the third one. It's called distribution fault analysis. You put basically effectively a computer at the substation that reads what's happening all the way on a distribution feeder and identifies that there's an anomaly. Something has changed on that distribution feeder from all of the voltage and power characteristics. And then now that you know something's happened, you can combine that with line sensors that'll tell you where the changes happen to triangulate in. And then the most exciting part is we found ways to leverage our smart meters. We have 5.5 million smart meters. These basically will tell you, because we read the voltage reading once every hour, you can take that data from 5.5 million meters using a machine learning model to tell you if there's something degrading on the secondary and service drop side. The secondary and service drop side is a challenging area for most utilities, including us. But what we found out now by doing this and running this at scale, it can tell us whether a small anomalies very small anomalies starting to form. And sometimes we'll send a troubleman, and the troubleman will look up at it and say, hey, I don't see anything there. And we're going, no, go unwrap the insulation. And when they unwrap the insulation, they find out, hey, you've got basically a wire that has frayed or something that has happened. And this stuff happens during storms, right? Storms happen, they shift the wires and connectors. You have connectors that chip, or you have insulators that chip, that all of a sudden it changes that pattern, and now we can detect it. There's a series of good catches that we call it good catches when it comes from any of these technologies. So that's the technology itself. It's a combination of the sensors detecting, but because we have this AI machine learning capability now, putting that to use to analyze a vast amount of signal data to separate the pattern from something unusual relative to something normal. And that's what we mean by really listening to the grid, We've now deployed the smart meters are across the entire distribution system. So that way you've got eyes, but you only have eyes on the secondary and the service drops. The other technologies we've implemented, it's right now at a penetration, so coverage, only about 5% of our grid in the high fire threat district is covered. Our goal is to steadily increase that coverage as quickly as feasible. And we're doing it in a way that we extract the most value from where we put it on the feeder. So I gave you a lot. So, I mean, would love to take follow-up questions there.
Yeah, certainly. Well, one thing that came to mind was, I think about the people who are out there installing this new technology. They may not be familiar with it. Do you have to do training ahead of time to sort of get them acclimated, or how does that work once it gets out into the field?
No, so there's two populations. I think the heart of your question is right. One, the installation of the equipment we do with our qualified electrical workers, our IBW. We do it with our regular crews who are familiar with working around the power lines. But we also have taken time to educate our crews, right? That process is not done, okay? Because this is new technology. So we're continuing the education process with our crews to tell them this is what the technology is, this is what it's doing, this is what, so because it's a new equipment that's coming on there. It's not that our crews are actually, a lot of times they're pushing for new equipment. They're seeing, because they're closest to it. They see the work, they see the catalogs, they can see and say, hey, why aren't we putting this new stuff on the grid? So they're very open to that piece. The challenge is not actually on that front. The challenge is taking all that information and integrating it with our existing processes for dispatch, making sure, here's the big issue that we are very careful about is we do not want to dispatch a troubleman to a location where we're not 100% certain that there's something going on. The worst thing we can do for that person is send them somewhere where we think there's something going on, but we don't know. And they go out there, to try and respond and waste their time. Our goal is to make sure that we make them more productive and not less productive. So that's what we've done. It took us a while to get to this, right? We'd been curating these for about 4 to 5 years prior to this, before the culmination where it all came together. And now it's starting to get embedded in our processes.
Sure, yeah, and maybe another piece of technology that might be coming out. I read about enhanced power line safety settings, EPSS. There's a lot of acronyms here.
Sorry.
No, it's fine. Can you tell me about how these technologies are being rolled out and what all does this include?
Yeah, so enhanced power line safety settings was really born out of the time period right in 2021 where we had a extremely high heat conditions and drought. So we didn't have wind in 2021. And so it was on enhanced power line safety settings has actually become a fairly mature program for us. What this is adjusting on the reclosers and the protection devices on your grid, adjusting the settings at which they will turn off. Now, most of them already come from a worker safety perspective, a setting that they call hotline tag. When you put it in that mode, anything that touches the wires, right, will basically trigger the device to shut off. And the intent was you don't want to have workers who are working things hot have any chance of electrocution or getting an arc flash. Well, hotline tag is extremely sensitive. So between a normal setting and a hotline tag setting, we found we devised a setting that basically will turn off the power in 1/10 of a second. The reason is because the time period, the amount of energy density is a square of the time. And so by cutting that time down, you actually reduce the energy density tremendously. Why does this matter for ignitions? Because if something contacts the line, the setting will trip off and the actual arc flash that happens will be significantly muted. Now we have a video on our PG&E YouTube channel called EPSS that people can actually see the difference in that arc flash if they look at the video. We have that now on basically our entire high fire threat district. So this covers the 25,000 miles. plus a buffer zone around it. So in total, actually 44,000 miles are protected with these EPSS settings. We don't put them on every day. We put them on when the conditions are right for it. So think of it as it's a staged protection. You know, on a normal day where things are not that dangerous from a fire setting, it's normal settings. As we get into the heat of the summer and the vegetation is dry and it's extremely low humidity, it's not ready for PSPS, but we know that it's elevated. When it's elevated, we enable EPSS. So we put the settings into some more sensitive. When it comes to when the winds start to pick up, basically that's when we turn off the power, right? So when it's really, really windy, it's really dangerous. So EPSS, PSPS is for the extreme danger. EPSS is when the danger is building. So you have protection in there. And it's reduced our ignitions by in the range of 70%.
Right. Well, always good to be more precise, working with a scalpel instead of a machete, as it were. Um,
Absolutely.
I was speaking with someone from Portland General about their wildfire mitigation, and he said some of the knowledge that they come across comes from their work with PG&E. So, could you talk to me a little bit about how your utility works with others to sort of test out new ideas and build new best practices in the industry?
Yes, I mean, to be honest with you, we owe a debt of gratitude to San Diego Gas and Electric. I think they started the wildfire journey significantly earlier than us. They started in the 2006 timeframe. And honestly, I think if we had paid attention to them and started to implement their practices on our system earlier, we could have prevented a lot of fires. So, you know, just the full acknowledgement of that. And then, you know, in recognition of that, what we do is we hold a conference once a year that we actively basically invite utilities to come in. We basically curate the information from a lot of utilities besides just us, and we share it broadly with them. So the conference will take place actually next week. And to give you a sense of this, there are 55 utilities coming from across the United States and Canada, and a couple coming in from international, from outside the US. And what we do is we produce a book. In fact, we can send you a link to the book so you can see it. I'll put it in the show notes if you want. And we'll have a new one that'll come out. That book basically says it's utility wildfire practices. We're very careful not to claim that they are best practices. And I want to spend a little bit of time on that because as much as we've learned, we want to acknowledge that the learning is not done yet. We are still in the infancies of this stage, and we need to learn from others as well as learn from our own practices. And the reason I don't say it's not best practice, because it may be a really good practice within my service territory, but my service territory is made up of a particular type of geography, a particular type of terrain, a particular type of weather pattern, a particular type of vegetation. And so what each utility has to do is really understand what is their service territory, what are the weather patterns, how are their communities being put at risk. And then from that, you can say, from the suite of technologies or the suite of strategies, this might make the most sense for me and for my customers. Because the goal is not to do everything, but it is to put what we call a layers of protection in place. Put the right level of layers such that, you know what, should one fail, you've got a backup and you have like redundancy built in. But if you go crazy and you put all the layers in, you're not really giving your customers that much more protection. It's the right layers that you need.
Right. Well, we all have constraints that we have to work within, and the question is always who's going to pay for it. But I always love hearing about how collaborative this industry can be. So thank you for sharing that, and I'd be glad to see the materials you mentioned as well. Um, Moving to undergrounding, can we talk? Undergrounding is probably another one of those things that needs to be right sized. So, how does PG&E determine what areas where undergrounding would be the best choice, or a better choice, if not the best choice?
No,
And in what areas would undergrounding not be the better choice?
yeah, I mean, there's uh, when I think underground can be sometimes a polarizing topic, I think, depending on the audience, right? I think when you talk to customers, customers that are in high fire risk areas all want their service undergrounded. And that's because they understand the value, and we can calculate risk reduction numbers of undergrounding being 99% effective, right? But it makes common sense. The challenge is, as you brought up, like how do you decide where is the right place to underground and where is a place where we probably should not put that amount of capital in undergrounding. So what we do is we have 25,000 miles of service territory in the high fire threat districts. We have a very sophisticated risk model called the Wildfire Distribution Risk Model. It's version 4 of the model. And we use that to prioritize where we should do it. And so we focus the undergrounding in the top 20%. The reason for that is because we think over time, that area is going to be constantly subjected to this wildfire risk. When you look past, 5 years, 10 years, 15 years, 20 years, you want to just take the risk off the table. So it's really focused by our distribution model that tells us where is this risk going to be persistent. And how do we know it's going to be persistent? So what we do is when we do that model, we make sure the vegetation layer is not a vegetation layer where, hey, a fire has just come through, so therefore there's no vegetation, so the risk is now lower. That may be lower for the few years, but once that vegetation comes back, those wind patterns that dictate that a fire will come there are pretty similar. And so that will still remain high in the risk, in that risk prioritization. We've also got to balance it a little bit, right? When you're trying to underground a circuit, there may be a section in an extremely high risk, but to do the work, right, you've got to take it out to a substation or take it out beyond a section. So there are a few areas that are just outside. So the vast majority is in the high risk, but for connectivity purposes, you would go a little bit beyond or a little bit on the side in that regard. Now, all of this is under scrutiny and regulatory scrutiny as it should be, right? So we're filing and what's called a utility undergrounding plan, an EUP, enhanced undergrounding plan, for us to really basically work within the guidelines that the Commission has now set forth to say, okay, this is how we justify why we're undergrounding. Here's the basis of it. Here's why this was selected. There's an intense set of requirements that we're following to highlight that here's why we're doing it, here's where we're doing it, and here's why we believe it is right. We've only committed to right now undergrounding 10,000 of our 25,000. So it's only 40% of the lines. And when you think about it, it's only across the entire system, right? We have 80,000 distribution lines. It's actually a small portion of that 80,000 that we think are right for undergrounding because the risk in those locations is so high. It will take us a while to get there. I mean, I don't want to underplay that. We crossed the 1,000 mile mark, and then by 2026, we'll hopefully have 1,600 done by end of this year. Now, it doesn't mean we're stopping overhead hardening. So a lot of people ask us, hey, you're doing undergrounding, are you stopping? No, we're still doing overhead hardening where undergrounding doesn't make sense. An example of, you asked this, right? Where's the areas not best fit for undergrounding? Sometimes the terrain is such that undergrounding doesn't make sense, where you have extremely hard rock, where you have floodplains, where you have very steep grades. There are locations. So it's very location by location centric. Water crossings, right? What you want to do is you want to underground where it makes sense and then harden where it makes sense. And there are some cases where a remote grid is just as feasible. And so we put a remote grid wherever possible.
A few times here you've touched upon sort of the impact of things like the wind and moisture levels. Can you tell us about the role that climate plays in all of this? I see from the website that your utility has installed something like 1,600 weather stations, and I assume those are networked together and used to model potential threats. So maybe you can tell us how this works.
Yeah, no, happy to. When we think about, climate change can be debated in many different ways, right? But as a utility, what do we feel? We feel the impact of what I call extreme weather events. This is when we get, in California, these atmospheric rivers that have been increasing in both volume and intensity. So the number and intensity has gone up. We get heat waves. July 4th on 2024 was an extreme heat wave. And then this year in March, I believe, the heat that we saw in our service territory was the hottest in over 100 years of recorded history. Now, for us to stay on top of it, we have a dedicated meteorology team, but it's not just the team. They needed devices out in the field. So that's kind of the 1,600 weather stations that we've installed over the last 4 years. And 1,400 of those weather stations have AI capability that projects out. The weather stations basically provide information inside via communication to the cloud. And those weather stations are also have the ability by any agency has access. So those weather stations, though we've installed them, are available fundamentally for the public at large to be incorporated into weather models being built by any entity, not just us. We've taken it and built models that will tell us basically, hey, when the weather pattern is such, are we going to see a greater number of outages? Now, wind and outage is very closely driven. New emerging science that we're trying to watch closely is the heat index and failure rates. Another example of that is think about lightning strikes. Lightning strikes, there's a higher incidence of dry lightning events happening across the globe. And in our service territory, we've seen it. But dry lightning that hits close to power lines does have the impact of damaging transformers. And so a transformer would start to, because there's lightning that has seen a surge, some of the oil would break down. The surge arresters would take care of if lightning hit your lines. It would ground that properly, but it still throws a curveball to the transformers. Now, those transformers don't fail immediately; they fail over time then. And so this is where this interplay between, hey, we know where lightning occurred. Now, because we have continuous monitoring, we're monitoring those transformers more closely to know, let's go change them out if we see any hint of degradation that has happened on them from those listening devices that are listening to the transformers. So that's a bit of that interplay. The network is not just between the weather stations, it's actually between the weather stations. What do we see on the grid? What are some new technologies we're putting in to listen or monitor the grid differently? Doing our best to integrate all of that together so we have a common operating picture on how to operate the grid more safely day in, day out.
Yeah, I remember a few years back when I first started covering this topic, San Diego Gas and Electric was one of the ones who was really paying attention to the climate side of things. So I think that supports what you were saying earlier. I wanted to ask also about, I know the fires in Los Angeles and Altadena and other places, those were, back in 2025, but I know the damage was catastrophic and the recovery is ongoing. So I just wanted to check in and see what work has already been done and what remains to be done there. How are wildfires being considered as the recovery work continues?
I think so. Those two fires happened outside our service territory, so they're not in our service territory. But that said, I think we're watching and learning from whatever happens anywhere on the globe. Okay, so
Definitely, yeah.
There's two elements to that. First of all, we looked and said what happened. So I'll give you two examples. Like the Palisades fire was, as you think about it, was a rekindle. There was an earlier fire that had happened that they thought was suppressed, and then everyone went away, but the underlying root system had fire, and that emerged, and then it emerged on a really dangerous day where it became the Palisades fire. So what we've done on our end is anytime there's an ignition from any of our assets, we send out our safety infrastructure protection teams with FLISR cameras to examine that, a couple times to make sure that we've caught this thing, so we don't have any rekindles at all. And I think that concept of rekindle is something that I think fire agencies across the US are now looking at more closely. There are these FLISR FLISR, they
The
say
FLIR
cameras, but
cameras?
yeah, the FLIR cameras. You can
Yeah,
use
yeah.
them. And we bought them for all of our teams to go out there and look closely to make sure at any of the hotspots, we examine that to ensure that if there's any hint of rekindle, you put some water, you squelch it while it's in this thing. Now, what we normally do is we'll do a assessment of it, and then if we find a hotspot, we'll call the local fire agency to come out because we're not in the suppression business, but we find danger, we'll call someone, and they're more than happy to come out and be listening. So on 27 of those that we looked at last year, we found actually 3 hotspots to indicate that it's a real condition, and now we're doing it more extensively. This rekindle check, all of that came out of the understanding of Palisades. On the Eaton fire side, right, it brought home for us that the importance of clearing under a transmission tower is extremely important. So what we've done last year, we cleared 4,000 of the vegetation around our highest risk transmission towers. And we thought based on our risk model that you need to do 6,000. We'll do the remaining 2,000 this year. We're in the middle of that work. And this is making a 50-foot defensible space. So you take around 50 foot around the transmission, you take the veg to a very low, and you actually have like a donut or absolute clearing to bare earth around the transmission now, so that if anything happens and falls there, it doesn't go anywhere. But the community rebuild is also, I think you were hinting at what's happening in the community rebuild space. The community rebuild is a challenge because people want to come back in their houses, they want to rebuild. The recovery effort needs to start. And I think supporting that effort, we sent actually our city crews down to help with right after the Palisades and the Eaton fire, we did the mutual aid. But we're watching closely because what we want is we want the rebuild to occur down there, but we want that rebuild to occur in a way so that those homes, should this fire come back in that area, doesn't result in an urban conflagration. And there's a lot of information that's put out by IBHS about community hardening, about home hardening. It's outside our service territory. Homeowners need to make those decisions. But we're hoping those decisions are informed such that when they rebuild their house, they build it in a manner that it can withstand potentially a fire if another fire unfortunately comes through that area. So the CAL FIRE has put out this high fire severity zone maps, and part of the new laws are requiring that if you're in those zones, you start the hardening process, especially for any new rebuilds, you build it to the fire hardened standards as possible. So we're watching that closely. It is a challenge because there's a lot of debates happen about where can veg be and where can veg not be. There are opinions on the table. We are firm believers in the zone 0 concept, the 0 to 5 feet, and then make sure the vegetation from the 5 to the 30 feet is there, because that's proven through science.
Yeah, people certainly enjoy their trees and their landscaping. It's the same here in Oregon.
I don't blame them.
Well, one thing I was wondering about, just as I was listening to you talk about policy, are there any coming or upcoming or recently adopted policies that are coming from the state or federal or local that are affecting the work of vegetation or vegetation management or wildfire mitigation? Or are there any assistances that are coming from those same places like grants or things like that?
No, I think I will commend California. I'll commend CAL FIRE for basically they do a lot of grants to allow vegetation removal, to allow the defensible space clearing, to support that efforts, and they've done that consistently. It's not as if they've done that they just started doing it. No, they've amped up the efforts, but they've been very consistent over the years in highlighting this fact. There's also the resurgence of fire safe councils. And Firewise communities, they've seen a lot of participation. They're using science as much as possible to triangulate what they should do, where they should do it. So that's really promising. On the legislative side, there's a lot of bills in the current in the current legislative session around wildfire, but all of them have coalesced around What last year a bill called Senate Bill 254 was passed, and what Senate Bill 254 was really a continuation fund from the Utility Wildfire Fund. But as part of that signature, the governor asked specifically that the California Earthquake Authority that administers SB 254, that they do a study to find out what policy decisions need to be made such that we don't find ourselves in this situation. And so it was not just about what the utility should do, it was what everybody in the community should be doing. What should society be doing in this case to take this wildfire risk off the table? Partly because even if the ignition stops being from a utility asset, it doesn't mean that that ignition may not happen from something else. And then you still have the devastating impact. On April 1st, the California Earthquake Authority, after a huge amount of input from a wide variety of stakeholders, published their report. It's available on the CEA website. If it's useful to your listeners, happy to provide you the link again on where they can download that document. But that's the document that's going to guide California legislative folks to take those ideas and put them into policy. Putting something into policy requires that debate, that thoughtful process that we go through. And so I think over this year and next year, we'll start to see policies coming out in regards to that. One thing I will give a lot of credit to the legislature for was the fire safe councils needed coordinators. What are these? These are coordinators in a county. That it's the county coordinator program. What that person does, funding that, they find out in that county what is the best type of work to do. How do you engage that community? There's a huge amount of engagement required. And they funded that county coordinator program. It cost $8 million a year to have somebody in all the counties full time. That was actually a big step forward, and that was funded. And so a lot of kudos to our political support for doing that.
Great. Well, thank you for that update. California, in addition to wildfires, is known for big technology. So AI obviously is a huge topic across this industry and other ones. Can you tell us some about the promising applications that AI or machine learning might have for wildfire prevention?
It's on the machine learning AI space, right? I think there's a lot happening across the board. So, but I think there are areas where there's large data sets that are yet untapped. Okay, so let me give you a couple examples of what we've already done, but then let me give you two examples of what's coming. So what we've already done was we had put up wildfire cameras as part. It started out by there was a basically with the University of Oregon as well as with the University of San Diego. There was a partnership, and the University of Reno, Nevada. There was a partnership that started quite a few years ago. Well, that has morphed into what became Alert California. And then that has morphed into what is basically Alert West. And what Alert West has these university consortiums, but it also has an anchor in a really strong private partner called Digital Path. That's basically pioneered a lot of the application of AI on the cameras. And that actually is a bit of a game changer, because in the middle of 2023, when all of the AI was put on all the cameras, we started to see that the AI detected the ignition faster than the satellites, faster in some cases than 911, and that signal goes directly to folks like CAL FIRE, that today CAL FIRE dispatches right off the signal. So the speed of response has also been enhanced. So that's one example of using AI. Now, in California alone, there are 1,200 cameras, but there are also cameras in Hawaii, there are cameras in Oregon, there are cameras in Idaho. The information from all of those cameras comes in because of this consortium type work, and it improves the AI improves the AI on all of the cameras, right? As you get those updates coming in and the new versions of the models get rolled out. So that is something super exciting, super interesting that benefits a lot of people. The other example is, and I touched on it in our weather stations, because we have this look ahead, because AI is predicting based on all the data we have, what is the wind gust going to be? We're sitting today on a Tuesday. What is the wind gust going to be on a Friday? What is the humidity going to be on Friday? Right? By doing that prediction in advance, it shows up in your weather models, so you can start planning and notifying people about changes in how you're going to operate your grid on those days. And PSPS is where we do the notifications because we're going to turn power off. But we can notify people where we're saying is, hey, you know what, the conditions are dangerous in this area. Or we notify our public safety partners in a good way about dangerous conditions. Where's the promise coming? So, I mean, we talked about continuous monitoring, right? We're going to go do upgrade the smart meter systems. So to put it in context, currently, we get a reading from the smart meters once every hour. We can speed that up and change that and say, okay, get me a reading once every 15 minutes. The next generation meters that we will be putting out, which are already there, right? It's just a question of deployment and then getting, the upgrade cycle. That gets you 32,000 readings a second. That volume of data, you need the machine learning to process, but what it'll give us insight deep into the grid, we believe. So that's actually hugely promising, and we'll see that in the next couple of years. The other one is, and I love this company, it's Planet Labs. And Planet basically scans the globe every day with a series of satellites. They have a whole series of satellites that scans the globe daily. They have a database going back, over 10 years that they've scanned. So they have in their data set what has happened prior to a fire, what has happened, over the course of what were the conditions like. Now, by applying machine learning, we can use that kind of in a way to go look back in time. It's not yet there, but Planet has a great relationship that they've done with Anthropic to use some of those models to go back and start to build and look and see if there are indicators of what things we're building, so that we can now look for them in the future. When we see the same evidence building up, we go, okay, this is appearing dangerous, preposition, take action, do that. I think mining data sets like that are going to be enormously valuable for us, and not just for fires, for storms, what's happening, the temperature in the Pacific. You can start to see, hey, if I look back in time, something that was this way in March, was it the precursor of what something is going to be in September? And that, I think, allows us all to prepare better. And so that's what I'm really proud, very, very enthused about and looking forward to.
Great. Yeah. Well, I know wildfires are a daily conversation at PG&E, so I really thank you for coming out and joining us in that conversation for a little bit. That's all I have for today. This is Andy A. Branches with VP of Wildfire Mitigation with Pacific Gas and Electric. Thanks again for joining us, Andy.
Hey, thank you, Jeff. Thank you for having me. Appreciate it.
No problem. And if anyone out there listening has any work with their utility similar to Andy's that you'd like to share with us, we would love to hear about it here at T&D World Live. So please drop us a line if you do. I'm Jeff Postlewaite, Managing Editor with T&D World, and thanks for listening.
Thanks again for listening to today's podcast, produced by Endeavor Business Media, a division of Endeavor B2B. To hear the latest information for power delivery professionals and industry best practices, subscribe to T&D World Podcast and visit our website, tdworld.com, where you can find insightful articles and sign up for our free daily newsletter.